Hey guys, this is such a fun looking problem. We have two circles with a radius of 5 meters, and then we have a square stuck inside here. And it wants us to find the area of this square. If you want to try this on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First step, I want to label the sides of this square x. So the area we're going to solve for is going to be x squared. And let's stick that right over here. Next, let's draw another radius from the center of this circle to the intersection point right here. And let's draw another radius from this point here to this tangent point. And that's going to be at right angles. Each of these blue lines are both radii of the circle, so they're both going to have a length of 5 meters. And let's extend this line right here parallel to this so that this will also be a right angle. So with this setup, this red portion of the line right here, it's the same thing as the height of this square, so it will also have a length of x. And since this whole thing has a length of 5, this remaining blue portion will be 5 minus x. And then let's call this green line y. We now have a right triangle right here. So we can use a squared plus b squared equals c squared. We can do 5 minus x squared plus y squared equals 5 squared. 5 minus x squared is 5 minus x times 5 minus x, which gives us 25 minus 10x plus x squared. And then we still have the plus y squared, and it'll be equal to 5 squared, which is 25. And then we can subtract 25 from both sides, and we can also subtract the rest of this stuff from both sides. On the left-hand side, we only have y squared, and on the right-hand side, we have 10x minus x squared. After we square root both sides, we have y is equal to the square root of 10x minus x squared. And now we can clean things up a little bit. Let's scoot this over here, and let's duplicate the y over here. Now this distance is going to be equal to this distance. So we know that y plus x plus y is equal to 5 plus 5. And we can clean this up a little bit. Y plus y is 2y, and 5 plus 5 is 10. And now we know that y is equal to the square root of 10x minus x squared. So in the place of this y, we can plug in square root of 10x minus x squared. And now we just got to solve for x. We can subtract x from both sides. That'll give us 2 times the square root of 10x minus x squared is equal to 10 minus x. And then we can square both sides of the equation. This square will distribute to both of these. So we have 2 squared, and then we have this stuff squared. 2 squared is equal to 4, and this square root and this square are going to cancel each other out. And then 10 minus x squared means this times this, and it ends up being 100 minus 20x plus x squared. Then we can distribute this 4. It'll give us 40x minus 4x squared. And then we can subtract this stuff from both sides so we can set it all equal to 0. Let's bring down the 100. Negative 20x minus 40x is negative 60x. And x squared plus 4x squared is 5x squared. All 3 of these coefficients are divisible by 5, so let's do that. We end up with 0 equals 20 minus 12x plus x squared. And then we can factor this. We need 2 numbers that add to negative 12 and multiply to positive 20. Well, that's going to be negative 10 and negative 2. So we have x minus 10 times x minus 2 equals 0. That means that either this equals 0 or this equals 0. So for x minus 10 equals 0, we can add 10 to both sides, and we get x equals 10. But we can see right here, since the radius is 5, there's no way that x is 10. So this is not a valid solution. And then for x minus 2 equals 0, we can add 2 to both sides, and we get x equals 2. This one is a valid solution. So now that we know x equals 2, the area of our square is going to be equal to 2 squared, which is 4. Let's give it a label of meters squared and put a box around it. How exciting.